Hi everyone, I'm recording this video to talk about the midterm 2. Okay, so here are some general information about midterm 2. First, this is a closed internet exam, so you should not do any Google searches. You should not share your file with other people. You should not send emails, and you should not chat with your friends when you're doing this midterm. Okay, and some students ask me this question: how about I want to do a watch the videos on YouTube, and this is conceptually using internet, and I say okay, that is fine, but you cannot chat with other people, you cannot send emails related to this exam, and you cannot post those questions on internet. Okay, and all the work should be individual work. You should not work with other people, and you can use the references, for example, your own notes, your own code, the class lecture notes, and the class videos, and then your own homework solutions. And you need to type your solutions. And this is a rule that I have been using in this class because at the very first time I teach this course, I had some really hard handwritten solutions, and then I decided I want to enforce it to type your solutions. And this means you have to find a handy tool to do the visualizations, because I'm going to require you to do some of the illustrations. And for example, it could be a tree structure. Okay. And here are some of the main topics you need to know. And the first thing, pairwise comparison-based search. Okay, so we are not talking about a specific sorting algorithm. Sorry, it should be sorting, not search. Okay, so I'm not talking about a specific sorting algorithm, but for all the sorting algorithms, as long as they are doing pairwise comparisons, then you should know they are omega and log n. Okay, and then you need to know what are the pairwise comparison algorithms we have discussed. Okay, and then we learn the linear time sorting. And for linear time sorting, we know the counting sort, we know the radix sort, bucket sort, and then the important thing is this part. So what are the assumptions and the limitations of those linear time sorting algorithms? And for example, can we use them to sort float numbers? And for example, if we have a really large range from 1 to 1 million, and then are those sorting algorithms really suitable? And you have to understand those limitations. And otherwise, you may find that linear time sortings are the best sorting algorithms, but in reality, no, they're not. And the time complexities, and you need to know, even though we say they are linear time, and you need to know what are the limitations. And for example, do we consider what is the range, expected range, and how many digits, etc. So those are all, there are limitations before we can really say they are really the linear time sorting algorithms. And other statistics, and we know two algorithms on the order statistics. The number one, randomized selection, and this is a selection similar to the partition for the quick sort, and this is the algorithm you definitely need to understand. And the second one, worst case linear time selection, and we are using the median of the median. Okay, so this one is really a good example for brain exercise in a algorithm class, but I'm not, as promised, I'm not using that as part of the exam. Okay, and binary search tree. And for the binary search tree, you first need to understand the binary search tree property. And for the tree box, there are three versions of the tree box, and we want to pay a little bit more attention to the in-order tree box. And why? Because for the in-order tree box, we can make use that to do a BST sorting algorithm. And then, you also need to understand why the BST based sorting algorithm is not a really exciting algorithm. Okay. And for the BSC, you need to know how to do a search. You need to how to do insertions, and there could be a iterative version or a recursive version. Okay, and then for both of them, and you need to be able to analyze the running time based on the height. Okay, and then you need to know how to get the maximum, how to get the minimum in a BST, and then you have to know how to get the successor. And after you understand how to find the successor, and then you need to do the deletion. And for deletion, there are 3 different cases, and the deletion is always a hard and tricky part in a BST. Okay, and then moving on, and we also want to you also want to study the red black tree or the arbitrary. Okay, and for the arbitrary, and there are a few more properties, and remember the arbitrary is first a BST or a binary search tree. Okay, so for the binary search tree property, and they also apply to the arbitrary. Okay, and there is a very important concept called black height, and you need to understand how to do the black height and why this concept is important to keep the arbitrary reasonably balanced. Okay, and for the time complexity of the arbitrary on the operations, for example, insertion, deletion, and the search, and then getting the max, getting the mean, etc. Okay, and for and when we do the arbitrary, we also learn the different ways of doing the rotation. You need to be able to do the rotation at least on a piece of paper. Okay, and then for the insertion, there are 3 cases we have discussed on the PowerPoint, and there are 3 more cases, and they are just the reverse version of the first 3. Okay, and for the deletion, as I promised, deletion won't be part of the exam. Okay, and the dynamic set, and dynamic set is really a abstract data type, and a dynamic set can be implemented using a different version of the data structures. For example, you can just do a normal array, or you can do a linked list, or you can do doubly linked list, or you can do binary search tree or a arbitrary. Okay, and using different implementations, when we implement a dynamic set, and then the time complexities of doing the basic functionalities are also different. Okay, and say if I'm using an unsorted linked list, and what is the cost of doing a search? And it should be linear. Okay, and then if I'm using a sorted version of the linked list, and what's the cost of doing a search? And you will say, okay, that is linear again. Okay, let me ask you another question. If I'm using a unsorted linked list, and then I'm doing a max, finding the maximum, and then what is the cost? That is linear. But if I'm doing a sorted linked list to implement a dynamic set, and what is the cost of doing a max? And it should be 0, 1. Okay, and then the next topic you want to study is hash table. And the first question is, why do we want to do the hash table? And the hash table, it can be another implementation of the dynamic set. And for that dynamic set, we emphasize that we want to do the fast query, we want to do fast insertion and fast deletion. And for the fast, I mean they should all be 0, 1. And we know and then we learn the hash functions, and there are a few hash functions we have learned in our lecture notes. And then for the collision, how do we resolve the collisions? And the load factor alpha, and how do we define the load factor alpha, and what is the range of the load factor, and then can this load factor really be greater than 1, etc. Okay, and then we have the division method, the multiplication method, and eventually the universal hashing. Okay, and the last part is the graph. So for the graph, we have learned the definition of a graph, and remember we have a set of the edges and the another set of the nodes, and then there are a few variations. And for example, do we allow self loops, and then do we allow directions? So A to B and B to A, are they the same or they're different? And then for the edge A to B, do we just consider all the edges A to B, B to C, and C to A? Do we consider all the edges to have the same weight, or we assume that all the weights are different? Okay, and what are the dense graphs and what are the sparse graphs? And then for the graph representation, how do we want to store a graph in the main memory? And we learn two ways: adjacency matrix and then the adjacency list. Okay, and eventually we learn the breadth first search. Okay, so those are all the topics you may see in the midterm too. Okay, so I believe this is the end of this video, and the next video I'm going to show you a few of the simple questions.